Hello, this is Shane Gibson with RackN, and today I am going to give you a quick introduction to the discovery process within Digital Rebar Provision. First off, let's sort of define what discovery is. Discovery is the process of taking something that you currently don't know about, figuring out what it is, and adding it as a manageable resource within Digital Rebar Provision. A discovered node is registered in Digital Rebar Provision and can be then manipulated by workflow. What do we mean by node? A node can be a couple of things. Traditionally in Digital Rebar Provision, we refer to nodes as bare metal machines. These are typically created via the PXE boot process, which is controlled by DRP. However, they can also be existing machines within the infrastructure. They can be virtual machines, or they can be containers. And they can be located anywhere as long as the individual node has accessibility to the DRP endpoint. They can be added and managed. The discovery process occurs typically in one of three ways. The traditional manner is through the sledgehammer OS image doing a traditional PXE boot, where the node boots via PXE and it loads the in-memory OS, which is what we call the sledgehammer image. The OS then does the registration back to the DRP machine to create the machine object for management by DRP. The other process we're also going to talk about is through the use of a Drp Join Process, which is a tool that allows you to add in external resources, either machines, containers, or virtual machines, etc., and have them registered automatically into DRP to be managed. These machines or devices or nodes don't actually go through the PXE boot process, so we don't gain control of them from the PXE boot methodology. And last, we can create machine objects manually through the API or CLI calls. So first, let's take a quick visual pass through what this looks like. We start with the DRP endpoint. We have an empty machines list. We have a node that we're going to PXE boot. So we PXE boot that node under DRP. It loads the in-memory operating system, and then that is registered back to the machine and is now put in the machines object list as node 01. For existing nodes, we have some examples here of a virtual machine, another server, a container. All of these nodes do an HTTP download of the DRP join resource, typically. Somehow you get that DRP join on the machine, and then that process creates registration back to the DRP endpoint, creating VM02, server 03, container 04 in our example instance here, and now those are managed under DRP. The last process is through the manual process, by which a service is registered through the API or CLI, so a direct API call, or the DRP CLI command itself is run, and the machine is registered on the DRP endpoint, and then voila, we have a workflow managed machines list of resources and that can be managed through their machine objects. We're going to do a little walkthrough of what that looks like in terms of actual operations. So if we take a look at the RackN portal, we currently have 3 machines here that are running a Kubernetes cluster through the crib process. These are just existing resources there. What we're going to do is we're going to kick off a bootstrap of a machine through the PXE process, and we're currently operating in the packet environment. So we're going to create a new machine where we're going to say PXE boot is the name of the machine in the EWR1 facility, and then we are going to create it of type T1 small, and we're going to go ahead and kick that off. That process takes a couple of minutes for it to create the machine and bootstrap the machine into the PXE operation, and then do the PXE DHCP process against the DRP endpoint. And then at the same time, let's go ahead and kick off some virtual machines in AWS. So let's go ahead and launch some AWS instances. We're going to just use the standard CentOS OS type here. That's fine. We'll say select those, continue, and we're going to use these really cheap, low-end resources. Let's go ahead and kick off not 21 of them, 2 of them. And all of these defaults are fine. Under the advanced details though, what we're going to do is we're going to actually run the Drp Join Process. So in this case, we're going to run as part of the user data process the actual Drp Join tool, and then we're going to launch those choose a key pair in case we need to log into them, and launch instances. Okay, so those will take a moment as well. So what we're also going to take a look at, if we come back to our portal here, we actually see our Pixie Boot machine has come up and has been registered into DRP. If we take a look at the machine object, we can see that all of the standard things we expect to see here. Since this was a packet device, we see all of the packet metadata related to it. We've also gotten our Go High inventory report and the default discovery process, in this case in the Discover workflow, has set the inventory data. So we've gotten our much more sleeker, slimmed down inventory data fields here as well. In a short bit, we should actually see the AWS instances join here. Okay, while we are waiting for those to kick off, actually they've finished here. We can see the AWS resources have popped up, and we have our Pixie booted machine. So for the AWS resources, we pop up and we see that we have our Go High inventory report, which shows the information about the virtual machine. We also have our inventory data, and we can see that its manufacturer is Zen, product name hvm.mu is how it returns back to us as a virtualized machine resource. For the existing instance, if we take a look at the existing instance, we have this non-Pixie node at this 9621 address. If we jump to that node, log into it, and we see that we're in this non-Pixie node instance, we come back to our DRP machines list, and if we run the join script and kick it off and fire it off, it's going to run, and now it's gone through all of the steps to register the machine, collect inventory and all of that, and now it's waiting for tasks to be run. So if we refresh this, we should see we now have non-Pixie node here, shows up as the resource, and we see we have the old change stage map. We have Go High inventory report, so we got our inventory report, and we got our inventory data as well. This happens to be a Supermicro based machine. But if you notice, we don't have any of the packet metadata. If you're familiar with our packet servers, we pick up the metadata service. So since we now have this machine under control, we can actually go to this machine and run the packet discover workflow, which is not part of our normal workflow on the initial discover process. And we kick that off, we see it's running the actual discover process, packet discover. And if we take a look again at the machine object, we will now see that we get our packet metadata back on the machine, including our important packet SOS interface if we should need to connect to the serial over SSH console service. So that is, in a summary, how to do discovery in Digital Rebar Provision across a number of different assets and resources. Thank you very much. Again, that was Shane Gibson with RackN. We'll talk to you again later.